Hello, today my graph is about a body which has been released from a height. It undergoes deformation. On striking it undergoes deformation like this. Then it regains its shape and again rises to the previous height. So for that, first let us consider initial case here. So at that time it is at rest. So that means velocity is equal to 0. Then it falls under gravity, which means that the acceleration is uniform. So if it happens, then the graph of Vt should be somewhat like this, straight line through the origin. It rises to a certain velocity like this. So here when it is about to touch, the velocity is maximum. Now after touching, this thing undergoes compression. So that means that the velocity now decreases. The velocity of its center, let us say its center, it decreases. And at its maximum compression, the velocity becomes 0. And it takes time, certain time. So that's why what happens here is, now the graph will be somewhat like this. The velocity decreases, and it definitely takes some time to come at rest. So it can be vertical here. It will be slightly inclined. So till here the velocity was increasing, then the velocity decreases. The velocity of its center decreases actually. So here it is at its lowest, which is equal to 0. Then after that it starts to regain its shape. So regain its shape, that means that the velocity now increases slightly, but in negative direction. So previously it was decreasing, now it increases in the negative direction. So that's why what happens here is now the velocity now increases in negative direction, which means it goes like this, and like this. So what now happens is, so previously it compressed from here to here, and it also extends from here to here. So that means what happens is, the change of this velocity should be same. This change should be same as this change. This should be same as this. The angle should also be same as this, but it is different from this here, from this. Now since we have assumed that it rises to the previous height, the collision here we assume that it's elastic. So elastic means that it must this velocity should be same as this. So if it is not equal, it seems equal. So if it is not equal, I must make it equal. Then from here it rises, and when it rises, it is under the influence of gravity. So that means the slope here should be same as this. Slope should be same as this. This slope should be same as this because of that g factor. So when it reaches here, the velocity is 0, which means this. Now what we have is, this slope is same as this slope, and this slope is same as this slope, because since it is elastic, the body compresses and it relaxes in the same manner with the same force. Let us say the same force. That's why this slope should be same. Slope same means acceleration same. Acceleration same means that the force is same. So that's why this should be same as this, and this should be same as this. And the area here is same as this area. It's because the displacement here and the displacement here should be same. This time should be same as this time, which means that the time from here to here should be same as the time from here to here. And also we have got to what we have got is this peak value here should be same. That tells about the value of velocity actually. Value of velocity. Excuse me. So these values tell about the top velocities that we have, and these values tell 0 velocities. So 0 velocities are here and here. So that's what happens with our thing, that with a body that compresses during bouncing.